All right, 9.4, areas of parallelograms and triangles. Area of parallelograms and triangles, I'm going to show you a few things that you may not have ever known. Okay, so pay close attention here. A parallelogram can be a square, right? It could be a square. Okay, we're going to say that's a parallelogram. I didn't draw it quite perfect. I didn't draw that right at all, actually. Okay, parallelogram. I'm going to show you how to find the area of a parallelogram, okay? Here's the deal. The very formula is base times height, okay? The area equals BH. The area is the base times the height. The base is whatever one side is, okay? Whatever one side is. For now, we're going to call this, we're going to say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 6. It's 12. 12, we'll say inches, okay? What is the height? If this is 12, I actually counted the boxes. What's the height of this?
5.
It's 5, right? Now, where do I draw the height? I could draw it here, right? Don't you agree that I could draw the height there? What about right here? Could I draw the height here? Isn't that still the height? Oh, ready for this? What about this? Is that still the height?
Yes.
It is still the height. Even though it's outside of the object, it's still the height, right? Right? It's still the height. Here's the deal. It's base times height, so this is 5. So then you tell me, what is the area of this object? So it's area equals, what's the base? 12. What's the height?
5.
So the area equals 60 squared inches. Notice how I wrote that. How do I say it? I say it squared inches. How do I write it? Inches squared. Do you see that? That's how you write it. You write it backwards the way you say it. 60 squared inches, and yet it's written 60 inches squared. That you need to get used to. Okay? Got to get used to that. Okay? Why is that true? Why is that? I'm going to do something for you here that I want you to see. We established that it was 12 times 5, which is 60. Okay. We already figured it's 60 squared inches. We know that. Now here's the deal. I'm going to do something here. Let's look at this. I'm going to cut this thing up here, and I'm going to cut it right here. Oops. I'm going to cut that piece off. Let's just say I cut that piece off. And I shoved that thing, and I moved that thing over here. Where will that end up looking like? Do you agree that it will end up, I didn't draw that very well at all, actually. Do you agree that when I do that, that it ends up looking like a what? A rectangle. Do you see that? And what was the height? 5. Do you see how it actually is 5 here? Do you see how it actually is 5? And the base is still 12. I didn't change the base. You see what I'm talking about? That's why parallelograms, it's base times the height, because you could take off that chunk of a triangle and move it over to the other side, and it will make a rectangle. Do you understand what I'm saying? It's not like that's very important. You need to know that you need to know that. It's just that you need to be able to play with these objects and see, oh, I get it. I see why it's 12 times 5. What about this? Did you know that all parallelograms, all triangles are exactly half of a parallelogram. All triangles are exactly half, the area is exactly half of a parallelogram. Let me draw you a triangle and you see if you can see it. I'll draw a very straight one for right now. Can you see that? Now, I have a question. Do you see that this right here could be, do you see that it's exactly half of another triangle there. That it's exactly half of a parallelogram. That this big object here, this big giant thing, this guy right here, is a parallelogram. Do you agree? And that a triangle is half a parallelogram, even if, it doesn't matter, even if I draw this thing not there. What if I drew this thing like this? Come on. Do you see how it's still a parallelogram? Do you see how it's still a parallelogram? For real? Do you see it? Where's the parallelogram? Can you see that it's right here, right? There's that, there's that, there's that, there's that, you know? Do you see what I'm talking about? Okay. What if I decided to draw the object like you see that it's still a parallelogram? It's still half of a parallelogram. I don't care what the size of the triangle. Let's do one that's really ugly and funky. Let's make a nice, tall, long, skinny one here. Can you envision the other half to make it a parallelogram? Or I could go that direction. You see what I'm talking about? You see what I'm talking about? I could go that way. You see what I'm talking about? It's still going to be a parallelogram. Triangles are, the area of triangles, they really are half of a parallelogram. So, think, if we're finding the area of a parallelogram, what's the formula for finding the area of a parallelogram? Shh. What's the formula for finding the area of a parallelogram, Sladen? Base times height, right? Base times height. If a triangle is exactly half of a parallelogram, then how would you find the area of a triangle? Listen again. If the area of a parallelogram is base times height, then what would the area of a triangle be? Triangles are exactly half of a parallelogram. So if the area of a parallelogram is base times height, then the area of a triangle is half of whatever the base times height is. Right? So the area of a triangle would be, area is 1/2 base times height. Half of it. Does that make sense? Now here's the deal. In this situation, what could I do? Where is this? I need you to see something here. What's the base of this? What's the base of that baby? Nope. Look, the base goes from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now about 9.5. Do you see what I'm talking about? Now listen, most of the time people think of bases as being what's on the bottom. Can't I twist that thing around? Can't I move that thing around if I want to? The base is 9.5. What's the height, people? What's the height? Yeah, it looks like it's about 2, maybe just a little bit more than 2. Do you see what I'm talking about? Do you see that? If I turn this thing over on its side, there's the base, there's the height, there it is. Did you know that no matter what I do there, and so you go 9.5. Well, let's do this. 9.5 times 2, base times height, comes out to, 19. 19. And then I have to multiply it by half, right? The base times the height is 19. So what's half of 19? We're back to 9.5. The area is 9.5 squared units or whatever, like inches squared or whatever we're talking about. Make sense? Try one. Let's just try a couple of these. I'm going to give you a couple of these, see if you can do them. I'm going to give you a... We're we're going to call this 4 centimeters. And we'll say the height is, does it matter? Are you going to try less? And the height is 3 centimeters. I'm going to draw in here. 3 centimeters. I want to know what is the area of that rectangle, of that parallelogram. Okay, so this should not be difficult for any of you. What is the formula, Morgan, for finding the area of a parallelogram? What now? What is the formula for finding the area of a parallelogram? What's the formula? The area is base times height, right? Agreed? Okay. What's the base?
4.
It's 4. Listen, if this is a parallelogram, and if I turned this thing upside down, what would be on the bottom? 4, right? And if it's a parallelogram, then you know that and this are the exact same size, right? So then the base is 4. So area equals 4 times, what's the height? 3. I've told you what the height is. 4 times 3, which is 12. So the area equals 12 squared centimeters. How many do you have? Area equals 12 squared centimeters. Okay. What about this then? I'm going to give you this. I know, that's what I'm going to fix it. I somehow made too many. Yeah, there you go. Tell me the area of that object, of that triangle. Okay, what's the formula, Morgan? What's the formula for finding the area of a triangle? That's the area for finding the area of a... That's the formula for finding the area of a parallelogram. What is it for a triangle? Half of that. It's half of that, right? So it's this. You just literally go, area equals 1/2 base times the height. It's half of it. And of means times. So 1/2 of the base times the height. What is the base this time? What's the base? 12. Wait, what? It's on top. Is that a problem? No. Right? It is a base. 12. Area equals 12 times, what's the height? 8. What is 12 times 8? 96. Am I done? Is it 96? No, it's half of that. What's half of 96? Area equals 48 squared inches. How many of you got 48 squared inches? What happened? Oh, okay. Did you get it? Okay. All right. There's really not much more than that. The only thing that they do sometimes, it's kind of cool, is they give you these crazy shapes that are neat, and you have to use what's called deductive reasoning. I'm going to show you what I'm talking about. I'm going to show you a really yucky one, and we'll see if you can figure this out. All right. Not drawn perfectly, but okay. So here's the deal. This is what I want you to see. I want to see this. Okay, if this, I'm going to draw this for you. Let's see here. I'm going to call this 2 inches, and I'm going to call this 5 inches, and I'm going to call this 4 inches, and I'm going to call... this in here, 8 inches, and this 6 inches. Can you tell me what the area of the whole object is. Hold on, just wait. I'm asking you for the total and all of this. I'm going to just draw a quick little green. You know, I'm talking about this, the area of the whole thing. Does that make sense? I want the area of the whole thing. See if you can figure it out, and then I will show you what I'm talking about. I'm going to show you, here's the deal. You know, there's just some things that you need to, like I said, do some deductive reasoning. Use some logic here. So I really want your attention up here, for real. Here's the deal. We'll use purple. Okay. How many objects are in that thing? Three. There's three objects, right? There's this parallelogram. There's this rectangle, and a triangle. Okay? How can you possibly tell me what the area is of this stuff if I haven't given you all the information? I have. You just don't see it. For this big, giant rectangle here, did I give you enough information to tell me the area of that chunk? What is the sides? First of all, what is the formula for finding the area of a rectangle? Length times the width. What is the length and the width? 5 and 8. So it would be the area of this guy here is 40 squared inches. Do you agree? That chunk there is 40 squared inches. With this triangle, though, how can I possibly know what to do here when I haven't given you the height? Or did I? I did. What's the base of that triangle? 4. What's the height of the triangle? 8. The height happens to be the side. Do you know what I'm talking about? It happened to be the side. That's fine. That's great. So 4 times 8 is 32. So the answer is 32 squared inches, right? Isn't it 32 squared inches? No. Why not? Because it's half. Triangles are 1/2 base times height. So it's not 8 times 4. It's 8 times 4 times 1/2, or divided by 2. Do you understand what I'm talking about? What's 8 times 4? 32. What's 32 times 1/2? Or 32 divided by 2? 16. That means this guy is 16 squared inches. Now, what about this guy? I don't know. In order for me to find the area of a rectangle, I have to know a length and the width. I didn't even tell you what this was. How could you possibly figure out what that was? What could you do to figure out what this guy is? I've given you enough information. Look, do you agree that, I'll put it in green. Do you agree that this right here is 8? That side is 8. Does that not also mean that this side is 8 of that rectangle? Agreed? Does that make sense? I'm going to show you again. I need to see some nods. If you don't give me any nods, I'm going to be like, oh man, they don't have a clue what's going on. If this side of the rectangle is 8, then this side is also 8. Do we all see that? You all follow that for real? I mean, that makes sense, right? I mean, if this is 10 inches, how much is this? Right? Rectangles, opposite sides, are equal, right? Okay, so if that's true, and we know that from right here to right here, which is the same, right, that is a total of how much? 8. Agreed? Well, from right here to right here, how much is this?
6.
That's 6. So from right here to here is 6 inches. Well, then how much has to be left up here? 2. Do you see what I'm talking about? There's 2. Because 2 plus the 6 make the 8 that we already know. You just got to kind of look around and be like, oh, right, oh, yeah. And once we know that, people, once we have that down, then we know that this is 2 inches. And then you go, well, then how what's in here? 2 times 2 is?
4.
Now what do I do? Now I have 40 inches in this guy, 16 in this triangle, and 4 up here. What do I do with them? Add them up, right? This is just How much carpet do you need? 40 plus 16 plus 4 ends up being 60 squared inches. Does that make sense? Does it make sense? You don't have to do, you have to do one of those on this homework assignment. Take your time. Look at it. Draw it out. Think. Write it clear. Don't write small so you can't see. Write it big so you can see. I'm only asking you to do one of these. Okay? All right, let me look and see. I may have given you enough for you to do your homework, I think. Let me look. Correct. If it was a square, but I didn't tell you that was a square. It did end up being a square, though, right? Yeah. All right. Yeah. Let's do this. Let's do page 434, 435, 4 through 12 even, and 22 to 27 even. There it is.